your coffee gently with those beans. Merrily, merrily, merrily roast, life is but a dream. Hello and welcome to yet another sub-series of critical coffee considerations, Merrily Roasting with Francis Peck. Now, why this other sub-series? Here we're really going to go beyond the unmodded popper and modify it electrically, hopefully without getting electrocuted, and to get to a better roast, to be able to achieve something similar to this Ikawawa roaster that you would buy for €1,000 or more. Up to this point, really the only modification was adding this kind of chimney at no cost. Now we need to be able to control the heating elements and the fan. And we're going to do this with the Arduino that you see here, this microcontroller. So in a previous video I already showed the arrival of this turbidity sensor. So I'll actually add the output here, and then this is just to kind of show you how this signal is changing. So it measures a voltage between 0 and 5, and actually it goes down when it becomes more turbid, more total dissolved solids, except if you're going from air to water, then it goes up to almost 5. But doing this kind of measurements on espresso or V60 brews, that will be for another video, just to show you the mechanics of these kind of electronics. What we really want to share in this video is hopefully how to start using a thermocouple for temperature measurements, which is, well, necessary to really control a roast. So I had this ordered from Kiwi Electronics, quite a nice name for a shop, and this arrived today, so I'm very excited to see what we can find inside here. Okay, so this is the paper. So I ordered 2 things. Here is actually the relay, and I probably should have bought a solid state relay. I think this will be okay for the first experiments. So with a relay, you're able to electronically control the power of another element. In this case, that can go up to what is it, 250 volts and 10 amps of current. So you would connect the hot wires at this side and then the Arduino at the other side. But we're not going to do a live experiment with 230 volts just yet. After my crash last week, I really don't want to take unnecessary risks, but this should be quite on the safe side with my Arduino, and just seeing if I can get a temperature reading with the amplifier here. So I have here some hot water and some cold water. Okay, let's get this open. Yeah. So how does this look like? Not sure if I'm going to be able to understand this in one quick go, Although, of course, if we look at it, there's some pins here. So, of course, this element which takes in the ground and the current from the thermocouple, which is here, and it kind of looks like you need to solder on these components for it to actually work, which is of course something I have never done before. And then we have here ground, SDA, A2, analog 1. So I guess those would be the kind of connections for that. We're able to kind of just plug this in. Well, so you can kind of already make a very kind of loose connection. I guess to do a quick experiment with this, that might work. So on your breadboard, you would then have to organize this appropriately. Let's see. This goes here. And what I kind of want to do is just replace the connections I had with this gravity sensor, turbidity sensor. So I am going to, for safety, unplug the Arduino so I can, at least at this point, safely redraw the connections a little bit. So A1, that would be this one here. Let's see, A1. Okay, that's one. Of course, ground to ground. Ground is kind of a confusing one in the sense that with a DC system and a battery, it basically just means, I guess, the negative pole. So ground would be coming here. Yeah. And then we still need to get our 5 volts of power, hopefully 5 volts. Where does it take in the power? A1, A2, A3, A4. So, okay, ADR, U in negative and positive. So basically I'm going to pause here and do some studying, and then hopefully in a later segment I'll show you how it got properly connected. So as you can see, I didn't take any unnecessary risk. Okay, so I went to the shop and bought a soldering iron, which was already plugged in. So this is getting hot, so should be really careful. Followed some tutorials, of course. Then have the breakout board sitting on top of the headers here where we need to apply the soldering. So the problem I was having was, I assume that just letting this rest on this is not sufficient to get an actual connection, because the test program for this board kept saying can't find the solder. So my hope is, after this acquisition, so getting a small station here. So I guess this is now really getting hot. And so this is first time ever soldering. So let's hope I get this right. Okay, I'll actually put on my glasses. So as I understood, what is important, well, first off, actually, for heat conductivity, it should already, you put a little bit on the tip. Okay. And then you basically have to heat both the header. Oh, wow. Okay, so we're already back, not even 5 minutes later. The way that I saw it was probably correct. At least I already plugged it in once at room temperature with the thermocouple being on the table, which is wood, so that should not conduct in case of a problem. At least the same program that gave a signal with the turbidity sensor gave a voltage output. You can still see it on the screen now. So now I've put it here in this water that previously I was heating up to boiling temperature. And let's see what kind of a reading comes out of it now. So that's actually sitting in water, but that shouldn't really change. Oh, okay, Arduino is on. It's not short circuiting. And are we getting a reading? Let's see here. Can we get some new information? Okay, maybe I have to reactivate serial monitor. Ooh, it's not available. Okay, so I will have work to do. I'll round up this introduction to Arduino programming and do some in-depth work to get this operational. Hope to see you next time. So what I learned in the meantime is that this is not easy. Let's call it an art. There's really so it's really important first to heat up the surrounding area, because you really kind of want the solder is just to connect your header, and in this case I'm already at trying, let's say, to solder the sensor parts where this amplifier is or should be connecting to the like what happened now is then basically the tin just connects to it. But once you've got a little bit on there, then it's easier. Okay, I'm actually proud is a big word, but at least it looks reasonable. tricky thing is not getting too much material on there. And of course, not making any kind of unwanted connections. So now I've done the base work. I'll have to let this cool down a bit and see how it ended up. Okay, actually just reconnecting it did make it operational again. So I didn't really want to touch this. Okay, so now it's out of the hot water, and then this is really loose connections, but yeah, room temperature. Okay, wow, something's happening with this electronics. Of course, you need to get the program here correctly also, so that that will require some googling, etc. See you next time, now for real. Now really the final part of this experiment. It's actually working. I already know because I did try it out, so I'm now going to plug it back in, but I just didn't want to jinx it by registering it, but this was like just 5 seconds ago. So as you can see here, it now finds after the soldering. So I did do a good job. Good for me, first time soldering it. I didn't break the board. And it's measuring temperature. So the cold junction is actually the temperature sensor on the board, because that's what you need to really be sure what you're actually measuring with the hot junction. And so now it's 24 degrees. So there, on these kind of K-type thermocouples, there's kind of a temperature error, and or maybe the soldering has some, maybe it had some impact on it still, so that might get closer to each other. But I'm having temperature readings. I'm ready to, well, plug this into my popper and follow the temperature. Yes. Okay, so see you next time.